Efficacy of pictures versus texts as communication tools is my personal favorite research interest as an educator. Here is the relevant common context on it. It is said that a picture is worth 1,000 words. Yes, it is, but not as popularly believed. A picture freezes those words. It has the same words and meaning for all viewers. Thus, to convey one set of meaning, the same import, express using pictures. However, to convey millions of meanings to millions of people, in fact, to each their own, write and share a text, not a picture. That is how Venn diagram, the pictorial representation of sets, is a masterstroke in ensuring certitude in communicating manipulations of sets. Applying the 4 arithmetic operations on sets is a challenge. For sets are collections, not one quantity like numbers. Pertinently, visualization of sets enable realistic representation of sets as collections, simplifying operations, and other manipulations on sets. Venn diagram are the chosen mode of visualization of interactions of sets. Named after the logician John Venn, it helps show logical relations and reasoning threads. It is a generic tool for a range of usage, such as probability and statistics too. Uses simple closed curves to show sets of anything on a plane. The closed curves most commonly used are circles or ellipses. The picture shows a very simple illustration of Venn diagrams. It visualizes one kind of logical relationships in families. Let us get started with how Venn diagrams are drawn. Each set is a circle, and whatever is within the circumference is in the set. Relative size of circles shows the relative number of elements. This is obvious. If common elements are expected among the sets, the circles overlap. The overlapped parts of circles kind of house the common elements, and the extent of common is the extent of overlap. All the circles are embedded in a rectangular plane, the much-needed universal set. The boundary of the rectangle defines what is in the universal set. The universal set needs a special mention. It plays a very central role in visualizing operations on sets. It is how we give body, realism, to the sets that are subsets to the universal set. Without the universal set, what is outside the set circle cannot be captured, defined, specified. Every set is unique, and this is also because it strictly excludes things. For example, the set of odd numbers excludes the set of even numbers. The visual integrity of sets demands that the excluded elements are also boundaried, made definite and finite, to be meaningfully computable in any ways. Thus, in the earlier example, the odd set must also be contained, defined. The universal set is the reference for the excluded. In effect, the included and the excluded make a set, the specific universal set. A specific significance of the universal set is in defining the complement of a set that is part of the universal set. Recall, the literal meaning of complement is making something complete. Universal set is so defined that it completes the sets by being what it takes to complete those sets. Here are a few examples of universal sets that have the role of completing the sets. For a set of animals and a set of plants, the universal set is the set of living things. Here, the set of plants is the complement of the set of animals. And the two together makes the universal set, that is the set of living things. Obviously, the set of animals complements the set of plants. For a second example, consider the set of polygons and its complement, say, the set of circles. The two together present the universal set, the set of plane figures. For a third example, consider the set of doctors and the set of engineers, and we get the universal set, that is the set of the two largest professionally qualified people. Briefly, universal sets are what given sets are parts of and need them to be meaningful exist. Let us now get to how we present set operations in a Venn diagram. First, a revisit to how we draw sets. Every set in a Venn diagram is a subset of the chosen universal set. The outcome of operation is of their own kind, a new set. But visually, the outcome is not a new set, a new circle. It is some combination of the circles and the space that represents the universal set. We shade or color off the outcome in the sets and the universal set. Venn diagram aids the process of finding operation outcomes. It does not create separate outcome set. Next, we set our sights on the specific operations. We start with the arithmetical properties of union of sets. Union of sets is akin to addition of numbers, and it parallels the properties of addition of numbers, such as the commutative property of union of sets. For example, uniting a set of even numbers and a set of odd numbers would be same as uniting a set of odd numbers and a set of even numbers. In the union of sets, the elements need not repeat because a set defines what is in it, and repeat entries of elements makes no sense. And it is because of the non-repetition of elements that adding a set to itself is the set itself. The elements of the set are not listed twice. Thus, the union of a set with itself is the set itself. Union results in a set. Similarly, a set plus its universal set is that universal set. Repetition of the elements of the set is meaningless. Next, the arithmetical properties of set intersection. This operation is relevant for sets and not for numbers. Numbers are just a set's size. In sets, we have what's inside the numbers. The intersection is a set of elements that are common to the intersecting sets. It draws its name from how the common elements among sets are shown in a Venn diagram, overlapping or intersecting circles. Intersecting set is a collection of things, elements, that may be common among sets. Intersection has properties similar to the union. For example, the common elements of set A and set B are same as the elements common to set B and set A. It is easy to visualize that a set is common to itself. All elements are common. A set has itself in common with its universal set. All its elements are in the universal set. The intersection of sets is a no-brainer. By now, it may be time to guess what may be the arithmetical properties of set difference. Difference is the sets correspond of the negative operations in numbers. Obviously, set difference is also a set, much like union, and intersection of sets yields a set. A minus b is a set that is a subset of AE. A minus b is the set that has elements of A minus all the elements of B. But know the big if here, the elements of B are taken away from A if they are in A. Consider the situation where set A is an empty set or a null set and set B is any other set. Then the null set minus set B is equal to the null set. Why? Because the null set has no element and there is nothing to take away from the null set. The null set remains. Here is an example of set difference operation. If A is the set of all numbers from 0 to 100 and B, the set of all numbers from 0 to 50, then A minus B is the set of numbers from 51 to 100. And 51 to 100 as a set is a subset of the set 0 to 100, the set A. Recall the subset of a set has all its elements in that set. But B minus A is what is left in set B after all elements common to A and B are taken away from B. Clearly, the set that is B minus A would be a subset of B, and that is not same as the outcome of A minus B. No less, a minus B is possible only if A and B have elements in common, including the empty set or the null set that is part of all sets. And, last but not the least, if A and B have nothing in common, then A minus B is the set A. We must touch upon why complement of sets is useful for operations. Here are a couple of useful situations. First, the complement of a set may be the solution. For instance, the elements that are absent are the complement of those present in any event, place. Second, the complement may simplify the problem. For instance, a set of absent girls is the intersecting set of the complement of all the girls present and the set of all girls or the universal set. At times, it is best to work with the complements of sets. Operations on sets are quite simplified by visualizing them using Venn diagrams. The universal set plays a useful role too. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.